Okay, so I got a beam. It's kind of a box beam here, put together with nails as shown here. Okay, I know that the nails can resist 3 kilonewtons, and I want to figure out what kind of load I can put. Notice I've got the loading of the beam. I've got a 3 kilonewton and P there. So what is P going to be to uh, uh, so that this thing does not break? Okay, I should know the space. Yeah, the spacing's 100 millimeters. There it is. Okay, so again, Q, which is the shear flow, lowercase q. Again, it's going to be force divided by S. Okay, so force divided by spacing. Now here's the thing. This is the area I'm going to look at, right? Okay. The thing is I've got a nail coming in on each side, right? So it's actually going to be 2 times F, right? It can hold twice as much. I've got 2 nails on it. So I'm going to basically double the amount of load that I can hold. So rather than 3,000 newtons, it can hold 6,000 because, again, there's 2 nails coming in there as I look at that area up there, right, that I'm going to take for my uppercase Q, okay? So again, there's a factor of 2 there because 2 nails are coming in on that top board. Okay, so VQ over IT. So let's go ahead and look at this. So V, I hope it's obvious, is 3,000 plus P. That's where the maximum V is occurring. Okay, it's going to be over at A there, between A and B, where it's got to balance both the 3,000 and the load P coming down. Okay, so that's the maximum V. Okay. Q is given by y bar prime times a prime, where y bar prime, that is going to be, let's see here, 150 minus 30, so 120, that would be 60 from the neutral axis is the center of that top guide, so 60 millimeters from that. Again, 120 total up. Okay, so I go up, yeah. Yeah, sorry. Um, and then it'll be times the area of that, which is 250 times 0.03. Okay, and that's going to equal 450 times 10 to the minus 6. Okay, that is Q on that guy. Okay, so I got V, I got Q, now I need I. So outer minus inner, essentially, so it's going to be 1/12, and then 310 is the base, 250, 30, 30. Okay, and then the height is 150. Subtract off the inner hole, which is going to have that would be 90 high and 250 wide. So the base is 250 and then 90 high. That's that inner hole there. Okay. From that, I get I, moment of inertia, to be 72 times 10 to the minus 6. All right, so now I can go ahead and figure this out. Again, what I'm trying to find is P there, okay, which is related to the shear force. Now, again, my shear flow, I have 2 nails, one on each side. Each nail holds 3,000, so it's going to be 2 times 3,000. They are 100 millimeters apart, so divided by 0.1, okay, and that's going to equal V, which is 3,000 plus P. That's where the maximum shear is. Q is 450 times 10 to the minus 6. And then I is 720 times 10 to the minus 6. Okay. Solving that for P, the maximum P that allowed so that I don't shear off my nails is then 6.6 kilonewtons. So it can handle that much load. Okay, and now the key thing here is again recognizing that the area that I'm looking at, I have a nail coming in on each side, so that shear flow is multiplied by 2 because again I've got 2 nails, thereby doubling the amount of shear that it can hold.